Hello everyone, welcome to Engineering Xplained channel. In this session, I am going to take Basic Thermodynamics Module 3, Lecture 7, that is Second Law of Thermodynamics. Already we have taken the zeroth law of thermodynamics and first law of thermodynamics. Zeroth law of thermodynamics gives the measurement of the temperature, and first law of thermodynamics gives the conservation of the energy, and there is the transfer of energy, and second law of thermodynamics gives the clarity for the transfer of the energy, that is the exchange of the energy, in which direction the energy will transfer and which form of the energy will convert into the other form. The heat is converted into work is converted into heat, and how that conversion is taking place, and the quality of the energy is taken into consideration in the second law of thermodynamics. As while taking the energy, we have taken the work as a high quality energy, high grade energy, and heat is a low grade energy. All the work can be converted into heat. Heat, all the heat we cannot convert into a work. And by that, we are going to take the second law of thermodynamics here. And there are two statements of the second law of thermodynamics. First one is Kelvin-Planck statement and second one is Clausius statement. Here these two statements are the negative statements. That means what is not possible, these two statements will give. A reverse of that is possible. And that statements we are going to take here, and in detail we are going to discuss about these two statements of the second law of thermodynamics. First one will take the Kelvin-Planck statement. The Kelvin-Planck statement of the second law states it is impossible for a heat engine to produce net work in a complete cycle if it exchanges heat only with bodies at a single fixed temperature. What is not possible for a heat engine? To produce net work in a complete cycle. It is not possible. When? If it exchanges heat only with the bodies at a single fixed temperature. If bodies at a single fixed temperature heat is exchanged, then it is not possible to produce a net work in a complete cycle from a heat engine. That explanation how we can take here. Here this is the heat engine which is interacting with a one reservoir having the single fixed temperature T1. It receives the Q1 amount of the heat and converts the heat into a work in the heat engine and producing net work that is equal to the Q1. And there is no rejection of the heat. Therefore, the Q2 will be equal to 0. This is the heat engine. Okay, it is heat engine producing a net work in a complete cycle. Okay, this is the cyclic heat engine producing a net work in a complete cycle, exchanging heat with a single fixed temperature, bodies at a single fixed temperature. And here all the heat energy will be converted into work, and it is not possible. And what is not possible, that is called as a perpetual motion machine of second kind, that is a PMM2. PMM2 is the perpetual motion machine of the second kind. If this is the machine works, that is a imaginary machine, and that is called as a perpetual motion machine of the second kind. What actually we know what is possible? Here this engine will consider. Here is a heat engine which is also working in a complete cycle and receiving the Q1 amount of heat from the source at a temperature T1 at a higher temperature, and converts the part of the heat into work as a W net, and remaining the heat which is not possible to convert into work is rejected to a lower temperature sink at temperature T2 with amount Q2, and that is the heat engine producing a net work in a cycle by exchanging heat at two different temperatures. Here, by exchanging the heat with a single fixed temperature, the heat engine cannot produce a net work in a complete cycle. Okay, that is not possible. It is given in the Kelvin-Planck statement. Then from that, the what is possible, this we are going to have. What is possible? This is possible according to the heat engine. This is a Kelvin-Planck statement. Moving further, Clausius statement. The Clausius statement of second law gives it is impossible to construct a device. This is also negative statement as I mentioned. It is impossible to construct a device which operating in a cycle. This is also operating in a cycle. Will produce no effect other than transfer of heat from a cooler body to a hotter body. Here, as we already know that the heat will transfer from hot reservoir to the cool cold reservoir. Okay, hot reservoir is having the higher temperature, and from that the heat will flow to the cold reservoir as because of the temperature difference. The temperature difference is the potential for the heat transfer, thereby heat transfer taking place. And reverse of this one, from the cold reservoir to hot reservoir, the heat transfer is not possible. That is given by the Clausius statement. Okay, that is, it is impossible to construct a device which operating in a cycle will produce no effect other than transfer of the heat from cooler body to hotter body. The one device which is, does the work of that, what is no other effect, no external work supply, nothing. Okay, that is no other effect producing, that will be transfer the heat from the lower body to lower temperature body to the higher temperature body, that is a cooler body to the hotter body, which is not possible, that is the statement of the second law according to the Clausius. Here we have taken one is concerned to the heat engine, Kelvin-Planck statement. What is not possible for the heat engine they have mentioned, and second one, what is not possible to transfer the heat. To transfer the heat concerned to the temperature, it is given in the Clausius statement. Next, here these two statements are seems to be different, but will give the same information and the same what the equivalence of these two, the what is not possible, they are going to give, and how that is those two are equivalent, that I am going to take in the next session, the equivalence of these two statements. Before that, the what is briefly given in these two statements we will discuss. According to Kelvin-Planck statement, it is impossible for a heat engine to produce a net work in a complete cycle if it exchanges a heat with a bodies of single fixed temperature. Okay, it is impossible for a heat engine. It is impossible to construct a device. Okay, produce a net work in a complete cycle, operating in a cycle. Okay, if it exchanges a heat with a bodies at single fixed temperature, produce a no effect other than the transfer of the heat from the lower temperature body to the higher temperature body. The three parts you can take here. The first one, it is impossible for a heat engine. It is impossible to construct a device. The second one, what it is, produce a network in a complete cycle. The second part here, operating in a cycle, the third part, what it is there, actually what it is happening, it will gives, that is, if it exchanges a heat with a single bodies at a single fixed temperature, it is third part in the Kelvin-Planck statement. In the Clausius statement, third law, produce no effect other than transfer of the heat from lower temperature body to the higher temperature body. We can divide the three parts in the statements of the both the second law, that's the Kelvin-Planck and the Clausius. Okay, the first part is, it is impossible for a heat engine, it is impossible to construct a device. The second part is, that is, produce a net work in a complete cycle. Here, okay, operating in a cycle we are going to have. Then third one, the what actually it is happening, that is, if it exchanges with a single fixed bodies at a single fixed temperature, and here it will be the produce no effect other than the transfer of the heat from the lower temperature body to the higher temperature body. In these three parts of the statements if you compare, then we are going to have the comparison between these two statements, and we are going to know that how the similar these two statements are there. I'm going to take the similarities, what it is there, the comparison, there is a equivalence of these two statements in the next session. Thanks for watching. If you like, share, subscribe, and comment.